Hello student friends, welcome to the channel that is physics point. The variations of the resistance with temperature. resistance मध्ये काय चेंजेस होतं टेम्परेचर चेंज झाल्यानंतर, या काही गोष्टी आपण आजच्या लेक्चरमध्ये स्टडी करणार आहे. देन व्हेरिएशन्स इन अ रेजिस्टन्स, व्हेरिएशन इन रेजिस्टन्स with temperature, variations in the resistance with the temperatures. Then the resistance of the material varies with the temperature. It is the property of the materials. The resistance of any materials, resistance of the material varies with the temperature, is the property of, of material. This is the property of material. The resistance of the materials varies with the temperature. This is called as, or this is the property of that material. The resistivity will be varies in the function of the temperature. Then the resistivity varies. In the function of temperature. That is, the function of temperature is K. I will show you the one of the relations between the variations of the resistance or resistivity with the function. This is the resistivity, and this is the temperature in a function, that is K. This is the resistivity of the rho, and this is the temperature in a function K. Then this is the 200, 400, 600 and 800, that is x-axis. And another one terms is, this is the 2 resistivity, 4, 6 units and 8 units on the y-axis. This is the 0. And resistivity varies in the function of K. It can be linear relations. This is the linear relations between the resistivity and temperature in the function of K. I'll be shows the linear relationship between these two. This is the resistivity, final resistivity or original or resistivity at the first side, plus 1 plus alpha into T minus T0. T minus T0. T is the final temperature, or T0 is the chosen referred temperature. That is, T0 is chosen reference temperature. I will choose one of the reference temperature here. This is the RT, is reference temperature, and rho 0 is the original, is the resistivity at the referred temperature, is the resistivity at T0. This is the all about equations I will be right here. then resistivity is equal to the original resistivity or resistivity at the T0, and T0 is one of the referred temperatures, referred temperature or reference temperature RT. Then T0 can be 0 degrees Celsius. T0 can be 0 degrees centigrade. T0 is a 0 degree centigrade. Then the alpha is equal to, this is the alpha, then alpha is equal to rho minus rho 0 divided by rho minus rho 0 divided by rho 0 into T minus T0. Then in the form of resistance, alpha is equal to R minus R0 into R0 into T minus T0. This is in the form of resistance, it is in the form of resistivity. Then alpha is the temperature coefficient of resistivity. Alpha is the temperature coefficient of resistivity. The temperature coefficient of resistivity is defined as the increase in a increase in a resistance per original resistance. Increase in a resistance per original resistance at a chosen referred temperature. At a chosen referred temperature, when they increase 1 degree raised in a 1 degree centigrade. 1 degree Celsius टेम्परेचर वाढल्यानंतर 1 डिग्री सेंटीग्रेड टेम्परेचर वाढल्यानंतर ॲट द रेफर्ड टेम्परेचर वेळेस जे काही रेशो घेत असतो increase in resistivity with the original resistivity. This is called as alpha. Then R is equal to R0 into 1 plus when as या ज्या रो ठिकाणी आपण R यूज केला त्याच या रोच्या ठिकाणी देखील आपण काय करायचं आहे R यूज करायचा. देन 1 plus alpha into T minus T0. This is the all about the equations for the resistance in the form of temperature. जर टेम्परेचर बदलला ही कोएफिशिएंट will be same, one is the same when resistance will be changes. When the change in temperature, resistance is also changes. It is the formula to give the relationship between the temperature and resistance. It is the linear relations. The change in resistance and change in also temperature. Temperature मध्ये बदल झाला तर resistance मध्ये बदल होतो. At a small difference in temperature, then alpha is equal to small difference in temperature. Alpha is equal to, then alpha is equal to 1 upon R0 into dr by dt. 1 upon R0 into dr by dt. This is the temperature coefficient of resistivity. Temperature coefficient of resistivity. यामध्ये ओव्हरऑल इक्वेशन्स मध्ये द व्हेरिएशन्स ऑफ द रेजिस्टन्स चेंज होत आहे जेव्हा टेम्परेचर चेंज झाला असेल तर. इट इज दिस वन इज द युजफुल अँड इम्पॉर्टंट इक्वेशन्स फॉर द फाइंडिंग द रेजिस्टन्स वेन द टेम्परेचर विल बी व्हेरी टेम्परेचर चेंज झाला असेल तर. आय विल बी सॉल्व वन ऑफ द प्रॉब्लेम फॉर द conformations of the given theory or given equations of the relations between the resistance and temperatures. I want just to give you clues or hint and you will be solve the remaining parts or remaining calculated part. Let's find this is the relations of for the copper. या कॉपर साठी दिलेला आहे. एखादी ॲल्युमिनियम कंडक्टर्स आहे आणि त्याची जी काही रेजिस्टन्स आहे, रेजिस्टन्स फॉर द ॲल्युमिनियम कंडक्टर इज गिवन बाय दॅट इज 2.5 ओहम ॲट 0 डिग्री सेंटीग्रेड. म्हणजे हे जे काय असणार आहे R0 असणार आहे. 0 डिग्री सेंटीग्रेड म्हणजे ओरिजिनल रेजिस्टन्स. दिस इज 0 डिग्री सेंटीग्रेडला म्हणजे R0. देन कोइफिशियंट टेम्परेचर कोइफिशियंट ऑफ रेजिस्टिव्हिटी देखील या ठिकाणी दिलेला आहे. अल्फा इज इक्वल टू 4 इंटू 10⁻³ पर डिग्री सेंटीग्रेड या ठिकाणी दिलेला आहे. देन अजून आपल्याला फाइंड आउट करायचं आर ॲट टेम्परेचर T is equal to 80 degree centigrade. Then and we know that T0 is a 0 degree centigrade, and I will be use of this formula. Then R is equal to R0 into 1 plus alpha into T minus T0. I will find here T minus T0 is equal to 80 minus 0. This is a 80 degree centigrade here, and this is the 80 degree centigrade, and this is the 4 into 10⁻³ then 0.004 coefficient. I will use the temperature coefficient. Then we know that R is equal to 2.5 into 1 plus 0.004 into 80 degree. Then R is equal to, you will be calculate the remaining part. This is only for calculating part, not using any formula and not be rearrange any formula. Okay.